Have any questions before we start? Okay, so I'm just going to do maybe one part of stuff. Okay, so this says find the order of magnitude of the following physical quantities. Okay, so the equatorial radius of Earth is that. Okay, so the radius of the Earth is 6.38 into 10 to the 6 meters. We'll do a quick calculation and then I'll show you the accurate way of doing it. But this is rounded to the closest power of 10, that's 10. This would be 10 to the 7 meters. So the order of magnitude is 7. Okay. So this is sort of easy, but okay, let's do okay, so I'll do another example. Okay, so let's say here's a number 4.9 into 10 to the 8. What is the order of magnitude of this number? We'll call it n. If you did the simple rule, this would be rounded to 1. The order of magnitude would be 8. Again, don't worry about this. If you did the accurate calculation, log base 10 of n is log base 10 of 4.9 into 10 to the power 8 is okay, so this works out to 8.69. So the order of magnitude of this number really is 9. Okay. But anyway, for garment work, we'll just do it quickly. Okay. We'll just round it to the closest 10, and that's how we'll do it. Okay. Okay, so the following masses are written using metric prefixes on the gram. Rewrite them in scientific notation in terms of the SI base unit of mass, the kilogram. So we want to write this in terms of kilograms. So I'll do 1 E 9 picogram. Let's see. Oh, 9 petagram. Okay, peta is 10 to the 15. Okay. So this is 9. Anybody know what's going on here? Nobody is in IT.
What software are you using to display that? Is it just the
No, it's screencast, I think.
Okay, I'll come see you after class.
Okay. Are you working in IT?
I work at AT&T, so
I'm sorry?
I work at AT&T, so I deal with after products.
All right. All right, so the prefix P was 10 to the power of 15. But so it's a gram. Now a gram is, okay, so 1 gram is, what is kg? K is 10 to the power of 3. So 1 gram is 10 to the minus 3 kgs. This 10 to the minus 3 kills the 10 to the power plus 3. Okay. So, and that is 10 to the minus 3 kg. Okay, so this is 9 times 10 to the 12 kg. So this in kg is 9 trillion kgs. Okay, you guys understanding this? Soccer fields vary in size. A large soccer field is 115 meters by 85 meters wide. What is the area in square feet? And 1 meter is that many. Okay, so area is length times width. Meter square, except that they want it in feet square. Okay, so the conversion factor would be, you want to cancel the meter, so 3.281 feet divided by 1 meter. Okay, that's the conversion factor you want, except that this is a meter square, so you need to square that. So this becomes meter square, will cancel the meter square, and you get your answer in feet square. Okay, so there is the conversion factor. You see, the Earth's crust is broken up into plates like that. Okay. Maybe you guys didn't pay your full fees. All right. Do you guys know what is the radius of the Earth? It's 6,400 kilometers, roughly 4,000 miles. Okay. And about 40 miles of this is 40 miles, roughly 40 miles. So that's 1%. Okay. That's the crust. That's broken up into plates. And this layer, the rock, this layer underneath, because of the temperature and pressure, is sort of plastic, it's melted. So you can think of this as pieces of wood floating on honey. And because of the heat rising, if you, let's say you put a pot of honey on a stove, heat it, put pieces of wood, because of the convection, these would all move. All the plates are constantly moving. They're moving at about 2 inches a year. And that's how fast your fingernails grow. Okay. So what we'll do is we'll convert it into an interesting number. Okay, so tectonic plates are large segments of Earth's crust that move slowly. So that's how earthquakes happen. So if one plate is lighter than the other plate, the total area is the same. So if one plate gets underneath another plate, it goes deep and it melts. Okay. Plates might get stuck against each other, and lots of energy. The motion is still there, and so when they release, they're releasing a lot of energy. That's earthquakes and stuff. All right, so we'll convert it into interesting numbers. Okay.
It's blank on the screen.
All right, so we learned a trick now. So for some reason it hangs up, and you make a change and it catches back. Okay, so suppose one plate has an average speed of 4 centimeters per year. Okay, 5 centimeters is 2 inches. Okay. What distance does it move in 1 second? So how much does a plate move in 1 second? Okay. Distance is speed times time. Yeah. So this is 4 centimeters, and I'll convert everything to SI units just because that's what we are interested in. Centimeters, what does that prefix C stand for? I'm sorry? 1/100. 10 to the minus 2 meters per year. A year is how many seconds? 365 days, 24 hours, 3,600 seconds times 1 second. So the second will cancel, okay? And that's how many meters a plate moves per second, okay? And here's a little trick that I like to use. Okay, so this is 3.65 times 10 to the 2, 10 to the 2, 10 to the 1, that's 10 to the 3, and 10 to the 3, that's 10 to the 6, and then when it comes up it becomes 10 to the minus 8. So 4 divided by 3.65 into 2.4 into 3.6 into 10 to the minus 8 meters. Okay, you can do it any way you like, so I'm just showing you the way I do it. Okay. All right. Now, scientific notation, normally what you do is you write this has to be a number less than 10, so it would be 1.3 times 10 to the minus 11. Okay. Well, no, 1.3 times 10 to the minus 9. But the reason I wrote it like this is, what is this guy? It's the size of an atom. Very good. So what we are saying is a plate moves roughly 10 to 15 atoms per second. That's how fast it moves. Okay. So now here's the reason this kind of problems are interesting is the following. Okay. Do you guys know the story behind the plates? How we thought that maybe the crust was broken up into plates?
Are you talking about Pangea and how it was originally all one continent? and then
I'm sorry?
Are you talking about how it was originally all assumed to be one continent?
Right,
and
right.
broke apart?
Yeah. But in the 1900s, early 1900s, scientists, or we had discovered that on the west coast of Africa and the east coast of South America, we had very similar fossils. Okay. And fossils of animals that couldn't have swum across. So Mr. Wegener, back in the 1900s, said maybe they were all together, one land mass, and they broke up and traveled apart. And of course, everybody laughed him off the planet. Yeah. So what we'll do is now we'll show you this calculation. From those numbers, we can show you that this is rough. He must have been rough. I mean, he was right. So we'll do a rough calculation. So we can look up, this is about 4,000 miles or something like that. So let's calculate how far a plate will travel in 1,000,000 miles. Okay, I think that's part of the problem. What distance does it move in? What is the speed in kilometers per million years? How far will a plate travel in 1,000,000 years? Okay. So we want to convert that into kilometers per 1,000,000 years. 4 into 10 to the minus 2 meters. And a meter is 10 to the minus 3 kilometers. And a year is 10 to the minus 6 million years. Did you guys understand this? This kills that, so that's a year. This kills that, so that's a meter. And 10 to the minus 2 meters is a centimeter. Okay. So this works out, this is 10 to the minus 5, 10 to the 6, so this works out 40 kilometers per million year. And if the distance between South America and Africa is 4,000 kilometers, let's say, that's 100 million years. So they were together about 100 million years ago. Okay. So you get the right order of magnitude. Okay. All right. All right, we'll do 2 more quick problems. Do you guys know the orbital speed of the Earth around the Sun? I'm sorry? No, the orbital speed. Okay, it's about 30 kilometers per second. Okay? So we'll calculate that. Calculate the average speed of the Earth's orbit in meters per second. Okay, so it'll come out to 30,000 meters per second. Okay. They tell you the Earth and the Sun, the average distance between the Earth and the Sun is, okay, so the orbital radius is 1.5 times 10 to the 11 meters. Okay. So the orbital speed would be distance divided by time. Distance is 2 pi r divided by time. And the time it takes for the Earth to go around is 1 year. Okay. So 2 pi times 1.5 into 10 to the 11 meters divided by 1 year is 365 days, 24 hours. Okay. So that's the speed in meters per second. All right, so 29. So roughly 30 kilometers a second, okay? All right, one more problem. Well, this is a Fermi calculation, okay? Here's an interesting problem. Assuming the human body is primarily made of water, estimate the number of molecules in it. So what are we going to calculate? We're going to calculate how many molecules of water are in your body. Okay. The molecular mass is 18 grams per mole, and there are roughly 10 to the 24 atoms in a mole. All right, so again, this is the Fermi calculation. So roughly your mass is, what is your mass? You guys know your body mass. Most of you are about 50 to 60 kgs. So we'll say 100 kgs is your mass, okay? And what we want is how many moles of water there are in your body, okay? It's 18 grams per mole, okay? So this mass divided by that, the mass cancels, and that gives you how many moles there are in your body. And there's 10 to the power of 24 molecules per mole. So this is the number of molecules, water molecules there are in your body. Okay. All right, so this is 100 divided by, and we'll approximate this, we'll call this 20 into 10 to the minus 3 kg into 10 to the 24. Okay. And the kg cancels with that kg, and the mole cancels. So this roughly works out to, that is 5 times 10 to the 27. Water molecules in your body. A 1,000 trillion water molecules in your body. Okay.